Hello, our topic is heart diseases prediction based on ECG signals classification. We are group 5. This is our contents. First, for the background, electrical diagram can reflect our heart's electrical activities, and it is one of the most critical factors for doctors to diagnose heart diseases and for detection and diagnosis. ECG-based automatic analysis methods can be widely used and can significantly improve the efficiency and accuracy of ECG classification.
The second part is about DMAIC. In this project, we focus on the classification and recognition of ECG signals. The main research content includes feature extraction and classification of ECG signals, and our datasets come from this dataset, which contains 5 different kinds of ECG. For the analyzed part, our project is important and meaningful because detecting patient symptoms as early as possible is important for some follow-up diagnosis and treatment. But in clinical analysis, the detection of accuracy highly relies on the experience of doctors. The performance of manual recognition of ECG signals is not satisfying. Even the most experienced doctors have only 75% accuracy. This fact motivates us to conduct our project with information technology.
To overcome the obstacles existing in manual detection, our goal is to achieve better prediction performance. We propose 2 possible solutions. The first is a low-complexity solution, which is logistic regression. The second is a highly complex but more precise solution, which is convolutional neural network. In the beginning, we take 2 steps to process our data. The first is dividing the dataset into training set and testing set. This step can avoid model overfitting. The second is making the training set balanced with both downsampling and oversampling method. For logistic regression, we use one versus one method to achieve multi-class classification. The input features are ECG signals and outputs are the classification results. The confusion matrix and accuracy report is shown here. This model can attain accuracy as high as 82% and guarantees fast convergence rate because of its simple form. However, when we look into the metrics other than accuracy, like the F1 score or precision, it is quite disappointing. It means that this model may cause a lot of false alarms. Therefore, we provide another solution which is a more precise model.
Compared with manual detection, logistic regression has achieved a much better performance, but it only treats the signals as independent features and does not consider the time series information. So, one more step, we try to apply deep learning models based on convolutional neural network to further utilize the time series information. The structure of neural network is shown as below. Basically, for each input signal, we apply one-dimensional convolution with 3 different kernel sizes, followed by 2 fully connected layers. The training process is shown in the left-hand side figure. For the testing result, the accuracy is over 98%, which means we have achieved a substantial improvement compared with both logistic regression and manual detection.
Another aspect of our improvement is that we improve the system performance or system efficiency from the aspect of communication cost and the learning speed. So there are a lot of well-developed new technology for wireless communication in recent decades. One of them is so-called fog radio network, which allows us to get access to any wireless devices. And also the distributed learning scheme is proposed. One of them is so-called the federated learning, which can perform machine learning over a distributed system. So by combining the new radio technology and the distributed learning scheme, we can propose so-called over-the-air aggregation federated learning for our proposed project. And the detail of our implementation is that we can get access to any home-used wireless devices and choose any of them as an access point. And by using this structure, multiple healthcare devices or the IoT devices can be connected to the network. And from the aspect of wireless communication, the over-the-air aggregation is dependent on an aligned wireless channel. And the pre-equalization method has been proposed to realize the so-called aligned wireless channel. And here we propose some of our results. We can see after the well-designed algorithm, the wireless channel can be actually aligned in advance. And based on this well-aligned channel, the over-the-air aggregation is possible or is practical. And based on that, the federated learning speed is much faster than the conventional digital communication. In conclusion, we improve our proposed method from two aspects. One of them is to improve it from the algorithm, and another one is to improve it from the system structure.